Hi, this is Dr. Anima Upadhyay, and in this video, we'll be talking about adsorption. If you want to learn absorption, please refer my previous video titled Absorption, a Bulk Phenomenon. Adsorption and absorption, they go simultaneously, and we call it sorption. So before I start this video, I would like to request you to please subscribe my channel if you have not done it so far, and also to like this video and share it among your friends. Now let us start adsorption. What is adsorption? Adsorption can be defined as addition of atoms or molecules of a liquid or a gas on some other material, forming a thin film of it on its surface. So in short, we can say that adsorption is a surface phenomenon. The material which is adsorbed on the surface forming a thin film is called adsorbate, and the material which gives its surface for the adsorbate layer to be formed is called adsorbent. Any material which is very porous in nature, which has high porosity, can be a good adsorbing material or a good adsorbent, such as clay, colloids, silica gel, activated charcoal. The adsorption phenomenon is widely used in many industries, such as the semiconductor industries, where solar grade silicon is produced. This solar grade silicon is doped with phosphorus and boron to enhance its optical properties, which is an adsorption phenomenon. It is used in removing the pollutants from air and water. It is used in removing the heavy and toxic metals from effluents. Effluents are industrial wastewater. It is used in separating the substances present in a mixture using adsorption chromatography. It is used to remove the poison from somebody's body who has accidentally swallowed it using activated charcoal and adsorbing the poison on it. It is used in masks of the mine workers to prevent them from inhaling the poisonous gases, especially in the coal mines. So there are so many applications of adsorption phenomenon. Now let us see the types of adsorption. There are two types: physisorption or physical adsorption and chemisorption or chemical adsorption. The physical adsorption is one in which the adsorbate is held on the surface of adsorbent by weak van der Waals forces, and it is reversible. In chemisorption, the adsorbate and adsorbent undergo chemical reactions, which leads to the formation of ionic or covalent bonds. Also, new chemical compounds are being formed on the surface. Therefore, this is irreversible. In physisorption, multilayers are formed. In chemisorption, normally unilayers or monolayers are formed. Physisorption decreases with rise in temperature, which is in accordance with the Le Chatelier principle, whereas chemisorption increases with the rise in temperature. Like any other chemical reaction, the rate increases with rise in temperature. Similarly, in chemisorption also, the rate increases with the rise in temperature. Physisorption increases with increase in pressure. However, Chemisorption remains unaffected by the pressure. So these are so many differences between physisorption and chemisorption. But there is one similarity also. That is, both the processes are exothermic. So we can say adsorption as a whole is exothermic in nature. To understand this, let us first learn the mechanism of adsorption. The adsorbent or the adsorbing material has in the bulk atoms, and each atom is surrounded by other atoms. So the forces are balanced in the bulk, but on the surface these forces are not balanced, and this leads to residual forces on the surface. These residual forces attracts the atoms or molecules of the adsorbate and holds them on the surface either by weak van der Waals forces or by chemical reactions and formation of ionic or covalent bonds. Once the layer is formed, it reduces the residual forces, which in turn reduces the surface energy that appears as heat energy. And this is the reason adsorption is exothermic. Now that you have understood the mechanism also, let us discuss one more term, that is desorption. What is desorption? Removal of adsorbate from the surface of the adsorbent is called desorption. So desorption of the adsorbate formed by the physisorption is easy, because just reverse the pressure and it will be removed. But in chemisorption, it is not that easy. We have to apply some voltage to break the bonds, which results into redox reactions, and the bonds are broken, and then the adsorbate is removed from the surface. So removal of adsorbate from the surface of the adsorbent is called desorption. Now let us see the difference between absorption and adsorption. Absorption is a bulk phenomenon, whereas adsorption is a surface phenomenon. Absorption is endothermic. Adsorption is exothermic. Absorption is not related with temperature. Adsorption changes with temperature. In absorption, the absorbate is uniformly distributed throughout the bulk. In adsorption, the adsorbate concentration changes from bulk to bottom. So these are the differences between adsorption and absorption. One more thing. The entropy decreases with adsorption, because we know enthalpy and entropy are the two functions of thermodynamics. Enthalpy is the sum of internal energy and the product of pressure and volume, and it is due to the regularity, arrangement. If arrangement of atoms is more, they are arranged properly, enthalpy is high. Whereas entropy is about the randomness of the system. Where more irregularity is there, the entropy is high. So when adsorption takes place, the system becomes more regular. It loses its randomness and therefore the entropy decreases as a result of adsorption. Now, I will give you a very nice example of adsorption. I have taken an aqueous solution of methylene blue and measured its absorbance using colorimeter at around 620 nanometer. And then I have taken a small weighed piece of activated charcoal and immersed it in this solution for about 20 to 30 minutes. After which I have removed the activated charcoal and again measured the absorbance at 620 nanometer using the same colorimeter and same Nasler tube. What I found is there is a decrease in the absorbance after removal of activated charcoal. Why there was a decrease? The answer to this question is before the immersion of activated charcoal, the quantity of solute was high, that is, the concentration of methylene blue was high. But after I immersed the activated charcoal for about 30 minutes and then removed it, the concentration of methylene blue reduced because some of the methylene blue was adsorbed on the activated charcoal. This resulted into a decrease in the absorbance. So the same principle is followed for the removal of pollutants from the air or water samples. Now, the amount of solute after the adsorption and how much solute is adsorbed by the adsorbent can be calculated by using isotherm equations. But I will be talking about isotherm equations and isotherms in my next video. Till then, take care of yourself and bye.